We would like to take this opportunity to officially welcome you to today's session, Emerging Trends in Building Decarbonization with Peter Rumsey. Peter Rumsey, founder of Point Energy Innovations, stands at the forefront of low energy and net zero building innovation with over 40 years of distinguished experience. Based in San Francisco, his engineering expertise has contributed to 50 LEED Platinum projects, the highest number by any engineer in the US. Renowned nationally and globally, he collaborates with top tech firms, educational institutions, and developers. Celebrated for his pioneering contributions, Peter has garnered accolades such as the Renewable Energy Innovator of the Year and ASHRAE's Award of Engineering Excellence. A Stanford lecturer for over a decade, he's also the visionary behind the Stanford Building Decarbonization Learning Accelerator, which equips academics with leading decarbonization insights and materials. Now I'll turn it over to you, Peter.
Great, thank you, Annette. Looking forward to today's session. I'm going to go through some of the concepts on building decarbonization, and we'll welcome your questions at the end. You can put them into the Q&A window, and then we'll go through those. So the thing about building decarbonization, we all know why it's imperative that we start focusing on this. We're seeing a lot of evidence of climate change. Some of it's dramatic. But I think some of the other reasons why decarbonization matters is that air quality is impacted heavily by the use of fossil fuels. Particles, NOx, SOx, all these different things are part of air pollution that's caused by the use of fossil fuels. The other thing to understand is that fossil fuels do disproportionately impact people of color. Black people in the US children are 10 times more likely to get asthma than white children. Most of that has to do with fence line communities living near fossil fuel processing and extraction facilities. I think that the other thing that's really interesting is that the cost of our gas infrastructure is increasing rapidly. Right now, the spending on maintaining the gas infrastructure has gone up by 300% in the last 10 years, plus or minus. And that's just only going to increase over time. Most of the gas infrastructure in the US is over 50 years old. Much of it's 100 years old. And it's going to cost a lot of money to keep that gas infrastructure going. So there's a lot of reasons that we should be talking about decarbonization. And I imagine many of you are part of the building industry, and we do play an important role. Buildings do account for roughly 40% of the greenhouse gas emissions globally, and the number in the US is also very similar. Within that, there's both the operational side and the construction side, and we'll talk about those. I think the thing that's exciting and a challenge for all of us is there's a lot of legislation that's now being passed and a lot of activity that's changing how we think about buildings. New York City, for example, now has their local law 97 for buildings over 25,000 square feet. They have to meet energy efficiency and greenhouse gas emissions limits. And some of those are going to be somewhat strict when we get to 2030. And in California, there's a wide variety of legislation that is getting passed around this. I think, one of the more important ones is the SB 100 that is saying by 2045, the electricity, 100% of electricity needs to be carbon free in California. I think it's also interesting in Texas that that's a state with the largest amount of renewable energy in the US, at 59 gigawatts and growing rapidly. And there's a variety of legislation happening in Texas as well. Oh, sorry. There's also a variety of different things going on at the federal level, but I think the most significant is this Inflation Reduction Act, the IRA. and its impact on buildings as well as energy production. There are literally billions of dollars available now for clean energy, but there's also a lot of money that's going to be available for buildings. Much of that is in the residential sector for building energy efficiency and heat pumps. But there's there'll be a large amount of that money will also be impacting the commercial and industrial sector. Another interesting act that was passed that we don't hear about as much is the Defense Production Act, where $500 million has been put aside to fund domestic manufacturing of heat pumps and other critical minerals. And I think that that's going to change the availability of heat pumps very rapidly. And we'll be talking a little bit about heat pumps today. So when we break down carbon emissions from buildings, there's two areas. One is embodied carbon, and we did have a seminar on that a couple of weeks ago where we dove into embodied carbon and how to decarbonize the construction of buildings. The other side and the larger side is the operational carbon, and that is the carbon emissions that's associated with using energy in buildings. And there's two ways that we use energy in buildings. One would be that we burn natural gas at the building, primarily for heating, different heating needs, space heating, water heating, laundry, but there's also cooking. So we're going to dive into operational carbon today. But before we do that, I did want to just remind everybody, for those of you who didn't get to attend the last seminar, is that the path for embodied decarbonization, that is the embodied carbon, is fairly clear. We can start by reusing existing buildings and doing renovations instead of building new. And remembering that embodied carbon is dominated by steel and concrete, or cement more directly. So reusing buildings is a really good thing where possible. In the US, that's a very doable thing. The next step is choosing carbon sequestering materials where available. Wood is one of those that sequesters CO2 into the wood that will go into the building. And now there's this whole emerging area of mass timber buildings, and we've worked on a variety of those, and it seems to be growing rapidly. And then there's the option of specifying low carbon materials. And a variety of manufacturers of everything from cement to steel are now offering low carbon materials. There's even a steel company in the US that's now offering what they say is a carbon-free steel, and that is steel that's made with electricity that's generated from renewable sources. And then last but not least, for the remaining embodied carbon that we can't get down to zero, we can do different types of high-quality carbon offsets to do that. And I'll give an example of a project where that was done. On the operational side, operational decarbonization, the path is also clear, if anything, more clear. If we take a typical building and start by making it more energy efficient, that's the first, and I would argue the most important step, and we will talk about energy efficiency today. And then making that efficient building all electric and finding electric ways to generate heat as the primary thing, and that I'll talk about that. And then last but not least is to power that efficient all electric building with renewable energy. And that can be either on-site or off-site. So I'll give some examples of that. In this quick time that we have together, I just wanted to share with you some of the energy efficiency blockbusters that have already made their way into the market. LED lighting is by far the most well-known. Some estimates have that reducing the need for several hundred power plants globally. The introduction of LED lighting, so it's been super significant. It permeates all different building types. But there's also the variable air volume box, which is a quiet but unsung hero in the HVAC world in commercial buildings. Before we had constant volume boxes, now we have variable volume boxes for delivering air. That's something that has reduced heating and cooling energy in commercial buildings by the heating and cooling energy by at least 50%. There's low emissivity glazing, which is also significant reducing building envelope loads. And I would argue that the variable speed drive is potentially globally equally as important as LED lighting, and not a lot of people know about that. But variable speed drives impact buildings, but also factories and a variety of other industrial uses. So there are several, and there are other examples of blockbusters in the energy efficiency side. So if we look at the ASHRAE standard 90.1 for building energy efficiency, which is a recommended standard, many states do use it as their building energy code. When we started with that standard in the mid 1970s, and we pegged that at an energy use of relative 100, and we look at the different versions of ASHRAE 90.1 over the years to where we are today, and there's actually a new version that just came out. We're seeing over 50% reduction in energy consumption, and this ASHRAE 90.1 is not that hard to meet with all off-the-shelf technologies today. I mean, most commercial buildings do come very close to meeting it, and it doesn't take a lot of effort to get over the line. So this is super significant. Not a lot of people understand that from the 70s to where we are today, buildings are using half as much energy per square foot. It's very, very big deal. What are the next generation of energy efficiency blockbusters? There are several, but my feeling is that heat pumps are really very much at the top of the list. Using AI for energy optimization in buildings is something that I think we're going to see a lot of over the next 10 or 20 years. I think building control systems, be they small or large, are very much dumb building controls, or let's call them smart time clocks, but we could do so much more in buildings to optimize the energy use. Induction cooking is going to be very large. I'll talk about that for a minute. Integrative design, where we think more holistically about the design of energy efficiency in buildings, that's going to be very important, and it is something that is growing. Personal comfort in buildings. The number one complaint of occupants in commercial buildings is too hot, too cold. And I think that we could do a lot for improving individual comfort in buildings. And that's where we really need to get to provide a higher level of comfort, because everybody wants something a little bit different. And there are examples of that that are now emerging. And it's somewhat connected to using AI. And then low pressure drop systems. One of the things that's near and dear to my heart, and I will mention that briefly. So if we put together all of the energy efficiency that is what I like to call state of the shelf, easily available but not commonly used. If we start with the baseline building, and this would be one that meets the ASHRAE 90.1 standard, and put together a more energy efficient building envelope, better lighting, better day lighting, that's part of that, improve plug load, meaning things that we plug in, better computers, better monitors, and low friction systems, meaning lower pressure drop ducts and pumps, and then put in a heat pump, we can get the energy consumption of a building down relatively easily by 40% plus or minus. And this building was that we modeled, and we've done it in a wide variety of climates. So this particular one was in North Carolina. And that building, then we put on 40% of the roof. It was a 3 or 4 story building. 40% of the roof we covered with photovoltaics, and it brought the energy use down further and met a significant chunk of the energy needs of the building. And then we covered the building with 80% of the roof with photovoltaics, and that on an annual basis covered all of the energy consumption. And then I think the thing that we're going to start seeing are batteries used in buildings. So I think that batteries are going to be another blockbuster that we're going to see widely deployed in buildings. So energy efficiency has a huge potential. We move on to building electrification. Remember, I said that the steps for the decarbonization are make the building efficient first, and then we electrify the building. The main tool that we're going to have in electrifying buildings is heat pumps. And the beauty of heat pumps is that for a gas heating system, we need to put in something like 105 or 110 units of gas to get 100 units of heat out. That's a good 90% efficient boiler. But for a heat pump, we can put 33 units of electricity in to get 100 units of heating out. And that's because heat pumps are able to pull heat from outside air and turn and change the temperature and deliver that as heat. And the waste product of heat pumps for some buildings is actually beneficial. That is, it's cooling. And so you can imagine a building where in the summer we're trying to make hot water for things like showers or a laundry, and our waste products is cooling. So we're working on buildings where, and Stanford's central plant actually has a system where when they need cooling, when they need heating, they capture the cooling and use that, and vice versa. When they need cooling, they capture the heat and use that if there's a simultaneous use. So heat pumps are very efficient and can provide a lot of benefits that gas boilers can't provide. So the forecasts for heat pumps are that there's going to be a very rapid growth in the use of heat pumps. This is already happening. It's happening very rapidly right now in Europe because they're transitioning away from natural gas for obvious reasons. But we're seeing a similar pickup in the use of heat pumps in the US. And heat pumps are not brand new. They've been around for quite some time. Combined heat pump air conditioner for residential use has been around for decades now, and I've seen that on houses all over the US. It's widely used, and that is a nice thing, is that you can get one piece of equipment that can provide both heating and cooling. So heat pumps are going to be a significant part of our future. When we're talking about electrifying cooking, gas cooking, we are all very familiar with that. And electric resistance cooking has been around for decades. Most people don't like electric resistance cooking for a wide variety of reasons. But electric induction cooking is what we're going to see that when we start moving to electric cooking. And electric induction uses a magnetic field instead of heating a coil. And the magnetic field heats the pot only and not the surface. And it's very rapid. It boils water faster than most gas stoves. And then it's also very precise in going up and down. So electric induction is going to catch on, and we're seeing that starting to happen. One of the things about gas cooking that's coming out now is that the indoor air pollution from gas cooking is significant. A recent study by Stanford, in addition to other indoor air pollutants that are caused by using natural gas, they found that benzene concentration from gas stoves is pretty bad in kitchens. And this is actually just came out earlier this year. Was a fairly significant finding. They did a wide variety of tests on that. So it's interesting, as we start to electrify homes, and this is sort of looking into the future, part of what we're doing at Stanford is trying to see how these things are going to go. We are anticipating that some homes will become electrified and others will still be using gas. And really the worst case scenario is if a house is electrified and the last thing they have is a gas stove. So we have to maintain the gas infrastructure, the utility does, for very small use of gas. And what will happen is gas will start to become very expensive because the infrastructure is the same, but the use has gone down. And so there is this idea of targeted electrification. If we can get a whole neighborhood, and this is where utilities would target programs, a whole neighborhood to electrify, then in that neighborhood, they can abandon the gas infrastructure and save all the money of maintaining that system. So this is looking into the future. This is not something that's happening next year. But if you play this out over the next few decades, this is the kind of thing that we'll need to start thinking about. Simultaneously, the cost of renewables and the adoption of renewables, especially photovoltaics, have been just accelerating. And you might or might not be aware, but in the US over the last few years, of the new generation capacity that was added in the US, 75–80% of that was renewables, solar and wind, and solar is the bulk of that. Similarly, battery storage is growing globally, is growing very rapidly and anticipated to continue to do so. Batteries being a really important part of having a high percentage of solar on the grid. And we're going to see batteries at the utility scale as well as at buildings. And utility rates are going to start to change to be time of use types of rates, so that the cost is higher during the periods when the sun is not available. And so batteries are going to become more and more economical. In several states, those kind of rates have already been implemented, and they're making batteries very cost effective. So another thing to be aware of on this, move towards renewables is 22 states have already put in place commitments, usually laws at the state level, saying that the grid needs to be 100% carbon-free by 2050 or sooner. As I mentioned, California has a 2045. So there's a lot going on, and I just wanted to share with you a couple different examples of these types of buildings. The RMI Innovation Center is one that's in Basalt, Colorado. So it's a cold climate, gets very cold in the winter, lots of snow, but it's also sunny. And so RMI spent some time thinking about this building. How can they make it a super efficient building? And RMI is a nonprofit organization that works in the space of decarbonization. They've been doing that for many years. And so they started thinking, okay, we're going to put in really good windows. And these are super windows that have very high insulating qualities. They're going to get a lot of daylight into the space. You can see it here. And they even this is the south side of the building. They've set up the building so that when the sun comes in, it hits the floor and heats up the floor in the winter months, but does not shine directly on the desks. So they don't have the desks right up at the window. So they get the daylight, they get the passive solar gain, and they get a highly insulated building at the same time. They even have chairs that provide individual comfort through heating and cooling, heating and then fan ventilation on the chairs so that people can get to the comfort that they want. The interesting thing about that, and they also insulated the building envelope, the non-glass parts of the envelope, very highly, is that it allowed them to eliminate the expense. They were going to put in, initially the idea was to put in a big ground source heat pump system. Heat pump, all electric, right? Nice system, but very expensive. But instead of buying the system, the expensive ground source system, they put more and more money into the building envelope till they got to the point that that wasn't needed. And so all they needed was a heat recovery ventilator and equivalent of 6 hair dryers of electric heating. So they put some small electric baseboards. It's a 15,000 square foot building. So that's a very small amount of heat. So it's not a heat pump, but it was so little of it that it made sense. So this is integrative design. Overall, the building costs less than what it would have cost if they put in the heat pump. So another project that I'm working on currently and that's under construction is the American Institute of Architects headquarters. in Washington, D.C. And this is a few blocks away from the White House. It's a building that was built in the 70s. And in that time, at that time, building insulation and good quality windows was not a thing. And also heating and cooling systems were not done in a way that's very energy efficient. So what they're going to do is they're going to replace the lighting, put in LED lighting instead of inefficient older fluorescent lighting, and better lighting fixtures, and they're going to set the building up for better daylighting. Instead of really dark glass, they're going to put in a lighter glass that transmits more of the daylight. They are going to put in a new glazing, double glazing, low emissivity glazing that lets the light in but blocks the heat out in the summer months. And they are going to electrify the building. So they're going to take the natural gas boilers that make steam, and they're going to abandon those, take them out of the building, and then they're going to put heat pumps on the roof to make the hot water. And it's interesting because with the reduction of the load from the lighting system and the oversizing of the building, even though they're adding all this new electric load in the heat pumps, they don't need to upsize the electric service to the building. So they are going to put some solar photovoltaics on the roof. This is a 7-story building, and that's only going to amount to about 10% of the annual use of the building. So what they're going to do is they are going to purchase off-site renewably generated electricity through this Pepco DC Power Connect program. And with the Power Connect program, you can select your generation provider. And there's a few options for generation providers that have 100% renewable. It's a combination of wind and solar. And the one that they're using is called Clean Choice Energy. And so they will be purchasing at least the part of their bill that goes to generation will be going to renewable energy. So they have on-site 10%, off-site 90% renewable energy, electricity for now an all-electric building. The interesting thing is about the embodied carbon of this building, reusing the building instead of instead of building a new building, is saving 76% of the embodied carbon. So they're just avoiding that embodied carbon by reusing buildings. So you can see that's the biggest step. But the next step that they're taking to offset the remaining embodied carbon, and it has a lot to do with the windows that they're purchasing, furniture, carpet, all the stuff that's going inside the building. And there is some steel structural upgrades and things like that. So what they're doing for that is they have purchased solar panels, and those have been donated to Habitat for Humanity, who's going to be installing those solar panels on low-income homes in DC and Northern Virginia. And those panels are going to avoid electricity consumption from the average grid that does have coal and natural gas in it, and that will avoid carbon. That's equivalent to the number of panels that they bought is going to avoid carbon from electricity that's equivalent to the embodied carbon of the new materials that they're bringing to the site. So I think that's a very creative way of doing an offset. Obviously, you don't have to do it in such a deliberate way. There's offsets that you can buy where people are grouping them together, and it's important to get high quality offsets. I'd say that this kind of offset is as high quality as you can get. I've worked a lot with a company in India called Infosys, and they are collaborators with Stanford, and they have 30 million square feet of offices throughout the country and 250,000 employees. So it's quite a large footprint as far as buildings. And they embarked about 10 years ago on a program to make much more efficient buildings, and then to go back to their existing buildings and retrofit them. Overall, over that period, they've reduced their electricity consumption per employee by 55%. I think it's probably the largest corporate energy efficiency program that's ever happened. And I think it's important to note that large energy efficiency improvements are possible in buildings. And one of my colleagues at Stanford, Jim Sweeney, did write a book, and it was based on research he did with his graduate students and postdocs over a 5-year period. They looked at energy consumption in the US, all sectors, and said, based on the efficiency that was available at the time in the earlier periods in the 70s when the oil crisis happened, and then compare that to where we are today. So how much fuel is consumed on an airplane per passenger mile over time? What about industrial production? How much energy, embodied energy, is in a car? Or they looked at buildings. So they looked at a wide variety of sectors in the US. And what they found was energy efficiency over the period from mid-70s until 2015 had provided more energy reduction than all of the new energy sources, domestic ones combined. And that they were looking at nuclear power, renewables, all these things were small compared to the gains from energy efficiency. So, for that reason, I am very much a proponent of decarbonization that's going to happen with energy efficiency. So I'm going to wrap up now so we can have some discussion. The key takeaways from this is that decarbonization is emerging rapidly for most clients in most markets. And I'd say some of it's being driven by legislation and such. But some of it's just being driven by, what the clients want. And then ultimately energy efficiency makes economic sense. So there's a wide variety of reasons that people are moving this direction. Heat pumps are rapidly evolving as the demand for them surges. And I, as a person who works in the design of buildings, where for commercial systems 3 or 4 years ago, there was maybe 3 viable options in each category on commercial building heat pumps. Now I'm seeing today that number be closer to 10. And I'm seeing a lot of people are calling me and saying, look, we've got some new stuff coming out. And I think that number will be more like 15, or by 2030, more like 20 plus options in each category. I think one of the more telling things was when I was at the national conference for building heating and cooling systems, the ASHRAE conference, one of the oldest boiler companies in America, in their display, had a huge display right at the center of their booth at that show with a heat pump. It's their first heat pump. So that was encouraging and significant. I think low carbon building materials are emerging quickly. Not only are commercial providers there, we're seeing a lot of research at universities on things like low carbon and zero carbon concrete and carbon sequestering concrete and cement primarily. And we're seeing a lot of research going to that. And we're also seeing venture capital money going in that direction. Energy efficiency remains a key element of decarbonization. And then most carbon-free electricity will be generated offsite. I do get this question a lot. Do we have to put solar panels on every building? Is that how we're going to get there? I think at the end of the day, solar and wind, the majority of it will be generated offsite at utility scale because it's more affordable that way. We are going to continue to see a lot of solar go on buildings because at the end of the day, we can generate electricity on buildings, on the roof of buildings, usually in most areas in the US, cheaper than buying it. And so solar is going to continue to be attractive on buildings. But I think the majority of renewables are going to be generated offsite. And that's how we're going to be able to decarbonize the operation of buildings. Thank you.
Thank you, Peter, for such an interesting and insightful presentation. Now we're going to move over to the Q&A. So I encourage everyone to submit their questions in the box on your console labeled Q&A. Now let's get into some of these questions. The first one is from George. Carbon offsets have been justifiably criticized from obfuscation, inadequacy, impermanence. Any comments?
Yeah, I totally agree, and that's why high quality offsets are the high quality is the important part of it. And I think what people are saying is, we could plant some trees as an offset, but what if those trees 5 years later or 10 years later get cut down, right? And then that offset is not an offset and actually could become a liability if that's composting and creating methane. So I really would urge you to spend some time, if you are going to go in the direction of offsets, for the embodied carbon in building the bit that's unavoidable, to really spend some time finding out, what is a quality offset. And I've been to a couple of conferences where there's a lot of discussion about that. Some are saying that the only quality offset that they can really count on is carbon removal, and that's where carbon, CO2, is taken out of the air. That is so energy intensive. There are questions about whether or not carbon removal is actually a valid way to go. So, that's why when we're working with the AIA, we said, let's do something that we know is really going to make a difference here. And that's where the solar panel solution came up. So we could have a whole discussion about offsets and how to go about that. But I do think there is some validity to it, but caution needs to be used.
Thanks, Peter. I'll move us over to the next question from Aaron. I believe that on-site renewables is more efficient, has less impact on the grid, and there are incentives for moving forward with this, but our capitalist society is penalizing this approach. More centralized energy generation is growing at a faster pace. What is your opinion on this topic, and do you think we should provide stronger incentives for more distributed generation?
Yeah. Well, there is a debate about, on-site versus off-site. There's a lot of advantages of distributed energy generation, and that, what I'm saying, is on-site. And it gives a resilience to the grid. A lot of if there's constraints on a grid, that is points, and as we electrify, this is going to be a little bit of an issue. There are points in the electrical grid that are going to become pinch points, and a lot of people are saying that one of the major barriers to full adoption of renewables is the power lines that are going to need to be built, and we need to build a lot of them to get power lines from where we can generate, if we do it centrally, to where cities are. And so that would say distributed is much better, because we don't need to build new power lines when we have the distributed, that is solar on roofs of buildings. There are still a good number of incentives, but the thing that's really a disincentive is the net metering that occurs. So each state has a different net metering solution. In California, there was recently a rollback of the net metering, so it's not as positive for people to have their own on-site generation. There are certain states where it's just they're basically net metering's not even available because for a variety of reasons the utilities don't want to see that. Now, I don't think it's possible to stop remote or on-site renewables, because once we combine, even if net metering is really bad, there's no place that's banned the use of solar. So you could have solar with battery and not feed electricity back into the grid and get a large percentage of your electricity generated on-site. You probably, in most locations, will still need some off-site electricity. So anyway, I am a proponent of on-site solar, but I do think that the solution is going to be a hybrid of on-site and off-site. So I'd leave it at that. But again, it is an important discussion to have, and each state is sort of coming up with a different set of solutions.
Thanks, Peter. Okay, so the next one, what do you see as the greatest barrier to building decarbonization at this moment?
I like that question because it's something that I think about a lot. And I think that 5 or 10 years ago, we could say that a lot of the technology is not there. I think now the technology is there. I think cost is still a barrier as we're still, figuring out how do we make this cost effective. Once people start doing it, Americans are really good at figuring out how to make stuff cost effective. And that's something that the world envies about what we do, is that we really have this ingenuity around figuring out how to make things affordable. So I think we're in that period now, and I'm seeing lots of solutions that are making electrification and energy efficiency very affordable. I think that the next thing that's there is people's understanding of, is it possible? Do we want to do this? Are there risks that we don't understand? I'm consulting with a large company, and they have the money, and the leadership at the company is on board with using solar and getting more energy efficiency out of their buildings. But what we're seeing is that the facilities managers are now becoming a barrier. Now, they're not being mean or dumb, nothing like that, but they're just saying, look, if I spend the time and energy to put solar on the roof of this building or change out the lighting or the chiller, I'll save energy. That would be good. And the money's got the company. But I'm taking risk. Like if I put in a new heating or cooling system, it could break. It's like a new thing, and it could break. One guy said, well, if I put solar on the roof and there's a hurricane and water leaks through the roof, then I could lose my job for that. But if he does the solar, he's not going to get any additional job security or bonus or anything. There's not incentives for the middle management people to do the right thing. So I really do feel that there's perceived risks, and people's approach to this is an important barrier. And there's actually a group at Stanford Business School that's studying what are the incentives that are needed at the leadership level within companies to get companies to change how they approach their carbon footprint or their energy consumption, these kind of things. And so I do feel that it's more than technology, it's more than cost. There's a human element here. And I think we should all be thinking about how do we incentivize and celebrate the people who accomplish these things. And what we're recommending to this company that I'm consulting with is financial incentives for mid-level management, facility management people that do the right thing. And a modest incentive that could be a very small fraction of the cost of an overall project of putting in a new chiller or a heat pump or solar, a small fraction of that cost can go to a financial incentive to the facilities management person. That would, in many times, be the barrier that we need to overcome.
Wow, yeah. I mean, I think incentive is huge. So yeah. How do we crack that nut? Okay, so our next question here is on one of our key takeaways, actually. Are there heat pump varieties which can replace portable window-based AC units? Can they be cheap enough to be used by low-income people?
Yeah, there are window unit heat pumps, air conditioners, combined units, and there's also the through-the-wall units that they use in hotels, lower-cost hotels. Those are also available in heat pump air conditioners. So it's the same compressor, but it's in a reversing mode, right? So it uses the compressor to make cold air in the summer, and then that same compressor, it's got a reversing valve. It works to provide heat in the wintertime. So they are available. They are more expensive than a cooling-only window unit, but it's not anything like double. It's like 20 or 30% higher. So yes, that is available even for affordable housing and low income.
Thank you. Moving on to the next one from Aniko. Can we get some more information from the Colorado Renewable Project that you mentioned?
Yeah, so RMI, the RMI Innovation Center, you can Google it. They've written several reports about the building because they really do want to celebrate it. Um, their website is rmi.org. That's the name of the organization, RMI. And if you Google the RMI Innovation Center building, and it's in Basalt, Colorado, which is right next to Aspen, you'll find some reports on that. It should be fairly easy. If you're having trouble, just contact me and I'll help direct you.
Thanks, Peter. Next one, has education in building decarbonization expanded so that future building systems have knowledgeable designers, engineers, and architects?
Yeah, our Stanford Building Decarbonization Learning Accelerator is specifically addressing that issue. I think that the next generation of architects, engineers, and construction managers need to understand this information. The thing that I've been teaching a class at Stanford on this topic for 15 years now, and my class size has doubled in the last few years. The students now get it that, hey, climate change is there. They've known that for a while, and there's a lot of things about distress around climate and everything. But what students are starting to realize is that there's a variety of solutions, and they want to understand what are those solutions. So we are seeing a rapid growth in interest in this area. But it's still, it's still early. Several of the universities that we're working with and providing teaching materials, and you can also go to our website and look at the teaching materials at bdla.stanford.edu. Those teaching materials or several of the universities that we're talking to are saying, well, we've got a program in talking about building systems or architecture or whatever, and we want to start layering in decarbonization. The professors are saying, yeah, I'm hearing that more and more. What is that? Can you help me out? And so I think that the courses that are going to teach next generation are, in a sense, being built out right now, so that within my estimation is that within the next 5 years, we're going to see most major AEC programs teaching and talking about decarbonization in one form or another.
Great. Your BDLA Center is doing great work. So thanks, Peter. Next question. Can you expand more on the profile of a mixed fuel house versus an all-electric house from renewable energy sources?
Yeah. So mixed fuel houses are the majority of houses in America. That is where we've got both gas and electric available. And, I think that the decarbonization of existing houses is going to take, it's a multi-decade project. First, I think it makes a lot of sense in new construction. If we're building a housing development or new construction remodels, it's easy to say, let's just do electric. And some cities around the country are now starting to implement building codes that are saying that new construction has to be electric. It's interesting because in the southeast of the U.S., and that is the southern states, the penetration of electric heating is already very high. The number is somewhere in the 70s. 70% of homes are already using electric heating of one form or another. Some of it's electric resistance, but a lot of it's also heat pumps. And same thing with electric cooking. They have the older electric resistance cooking, not as good as induction, but induction will start to take over that market as well. So there's a large part of the U.S. where 100% electric homes is already a reality, like a high percentage of them. And so I think when we're talking about this, we need to remember it's not like a weird new thing. This is something that's been around for a while. And if we just layer on more efficient homes with simple technologies and the current state of the shelf of things like heat pumps, induction cooking, we're going to get homes that are efficient, but also provide really good services. Generally homeowners don't care a lot about, all these things, decarbonization, but they really do care a lot about comfort. and well-being in a home. So, when we have a new stove, if the induction stove provides better service, that's what's going to make people happy and feel like, okay, this is the right thing. I think what we're going to find with new heat pump air conditioners is that they provide better service. With the controls, they can provide better heating and cooling. It's more precise. It delivers it at the time when they want it, and then it's done in a way that's more reliable because they have just a single piece of equipment. They're not owning a furnace and air conditioner and all this other stuff that they have to maintain along with that. So, yeah, I do think that this all electric is going to be the way things move, and the hybrid house, the combined fuel is going to be slowly something that's not interesting. And part of what will drive it, and what I was trying to say, is the cost of gas will get more and more expensive. And so that it's going to be less and less attractive to people to have the hybrid house.
Yeah, that makes sense. Everything is already very expensive, so cutting costs on some gas would be nice. Okay, so next question. How will society handle risk of relying on one energy source, like electricity? For example, in the future, if outages happen at the transmission level, only those with backup energy storage can have power availability. But on the worst days, such as when there are several days of rain, this could be a risk for even those who have solar battery. Do you see hydrogen having more role?
Yeah. So, there's a lot there as far as reliability, the grid, and those kind of things. I think that, the reliability question of electricity, and I live in California, we're very familiar with power outages because we've had these. We didn't have them this year because the fire season was, basically non-existent because we had good rain last year and snow. But the subsequent years, we had, for several years, fires, and the electric company would turn off the power grid in certain areas to avoid those wires, coming in contact with trees and starting new fires, right? So there are some questions about the grid and reliability. So the thing to understand about gas appliances is that for safety reasons, all of the modern gas appliances, not the old ones, but the new ones, require electricity to operate. We're not going to, a gas furnace doesn't work without electricity. Sorry. Gas stoves, the newer ones that are like 15 years and less, require electricity. They have the interlock so that you can't use the gas when the electricity is not available. So, gas is also vulnerable. This vulnerability can be offset, the electric vulnerability, with storage, as the questioner mentioned, and that storage will be available not only at the utility level, but also in a distributed way. So I think we're going to see more and more storage, and then solar distributed, another reason why distributed solar is a good thing. So I think there's ways that we can make the electric grid more reliable, and that's fairly obvious. As far as hydrogen is concerned, we will see a lot of hydrogen in the future. There's no doubt that hydrogen will be critical in industrial processes. There's a lot of industrial processes that just need heat, and we can't get exactly what we need with electricity, and it will be more affordable to do with hydrogen that's generated with renewable power. So a wide variety of technologies are being investigated in industrial processes where hydrogen becomes the key thing. There's a lot of discussion about using hydrogen in long distance trucking, for example, is another area. And there is discussion about using hydrogen in homes. And there's been different research projects on that and tests of that. A lot of people are saying that that's going to be a tough sell in homes as compared to electricity. We can't use existing gas pipes with 100% hydrogen. You can use 10% hydrogen, but if you get above that, the hydrogen starts to decay existing piping that we use, the steel pipes and the different PVC pipes that we use for gas don't work with hydrogen. You have to have a new pipe material. So putting in a new hydrogen infrastructure is probably going to be more, in most areas, for homes, is going to be more expensive than just electrifying. So hydrogen's part of our, I'm sorry, hold on. Hydrogen is part of our future, but the jury is out on how big of a role it will play. Yeah.
Okay, thank you. We have time for just about one last question. So I will go with the next one, which is, I am curious to know what the role of structural engineers is in the road to building decarbonization and net zero.
Well, I think structural engineers are critical on the embodied carbon side of things. There's, the structural system in buildings is the #1 thing for embodied carbon. So steel and cement, that's eventually concrete. Those two things are depends on the building type and everything, but they can make up 75% of the embodied carbon. So in its discussion about decarbonization, structural engineers are becoming front and center. Now, if we take a building where it's efficient, it's electrified, it's connected to renewable energy, that's pretty easy to do in a lot of areas of the US today. It's not a hard thing. But what's left is the embodied carbon. So there's lots of buildings that I'm working on that they're like, well, thank you, Peter. Now we've got a problem with the embodied carbon. It was always a problem, but now it's a bigger percent of the carbon footprint of the building. And so structural engineers are becoming a very important part of that discussion. So I'd urge you to start digging in and looking at alternatives to steel and concrete structures, mass timber and such. But then within the steel and cement categories, there's a wide variety of options that are lower carbon, and starting to learn about those. And, some of those have already been available and are widely used, things like fly ash and cement and such. So, yeah. Great.
All right. Well, Peter, thanks again for this interesting and insightful conversation and for answering all of the questions that we had time for. To everyone in the audience with us live today, thank you for all your questions and participation as well. I want to remind you that today's session was recorded, and a link to this will be made available to all of you within a week. So look forward to that email in your inbox, and have a great rest of your day. Hope you all enjoyed our session today. Thank you.
Thank you.